We'll see the abnormal combustion in case of SI engines. In case of SI engine, consider this as a combustion chamber where from A to D, this is the flame propagation path. This is how the flame is propagation. Now A is the source of ignition. Now due to this ignition, a hollow nucleus to be formed and flame front to propagate further. It will propagate further. Now B to B dash is the intermediate position of the flame front. Now C to C dash is the intermediate position of the flame front. C, C dash and D, the sprocket is the unburnt end charges reaching at critical temperature. So when the flame is propagating toward the end of combustion chamber, here at the end, the unburnt charges have extreme temperature and they reaches to very critical high temperature. In abnormal combustion, the end charges auto ignites before the flame front reaches at this location. So even though the flame is somewhere here, the charge get auto ignited due to the excess temperature created at the end of the combustion chamber, and this phenomena is known as the abnormal combustion and detonation. Now due to the auto ignition of these charges, here sudden combustion happen or shock waves are created because the flame is propagating here and sudden this mixture get burnt out. Now from the figure we may see the concept is known as detonation. The flame front has reached BB dash and the unburnt charges has reached the critical condition for auto ignition. In this case, there is a possibility of detonation. If the flame front can proceed from BB dash to D and consume the unburnt charge in a normal manner prior to completion of the ignition delay period, there will be no detonation. If, however, the flame front is able to proceed only as far as to C dash during the ignition delay period, then the remaining portion of the unburnt charge C dash D will auto-ignite and cause extreme pressure fluctuations from about 50 bar to 150 to 200 bar. We have observed that in case of normal combustion, the pressure reaches to maximum 26 bar, but in case of such an abnormal condition, the pressure reaches up to 200 bar also. Now, why this happened? Due to the pre-ignition. What is pre-ignition? The increase in the rate of heat transfer to the walls may cause the local overheating, specifically of the spark plug also, which may reach a temperature high enough to ignite the charge before the passage of spark. This phenomenon is called pre-ignition. Pre-ignition may also be caused by overheated exhaust valve or glowing carbon deposits in the combustion chamber. So in the combustion chamber there are many spots where the pre-ignition may occur even before the actual normal combustion. What is surface ignition? Under certain conditions, air fuel mixture is ignited by a hot spot in the cylinder. Initiation of the flame burn by a hot surface other than the spark is called surface ignition. The hot surface may be the spark plug, insulator or electrode, the exhaust valve head, the combustion deposits on the combustion chamber, etc. Surface ignition occurring before the spark is called pre-ignition and that occurring after the spark is called post-ignition. Now what are the effects of the detonation? Very first is the noise and vibration. The presence of vibratory motion causes crankshaft vibration and the engine runs very rough. Mechanical damage. The engine head and valves may be pitted. Increased rate of wear may occur. Carbon deposits. Detonation results in increased carbon deposits. Increase in heat transfer occurs due to the scoring away of protecting layer of inactive stagnant gas on the cylinder walls due to pressure waves. Decrease in power output and efficiency due to increase in the rate of heat transfer, the power output as well as efficiency of a detonating engine decreases. Pre-ignition. The increased rate of heat transfer to walls cause local overheating of spark plug which ignites charge before the spark that causes the pre-ignition. Control of detonation. How the detonation is controlled. So by controlling following engine variable, detonation can be controlled. Very first is increasing the engine RPM. retarding the spark timing, reducing pressure in the inlet manifold by throttling. In supercharged engine, reducing supercharging pressures reduces detonation, making the ratio too lean or too rich preferably later and to the water injection. Using the low compression ratio, increasing the turbulence, relocating spark plugs or use of two or more spark plugs, suitable combustion chamber design to reduce flame length and to reduce temperature of end gas. It can be eliminated by using high octane fuels or by adding additives known as dopes to petrol. Now, this is a question or an assignment. What is ignition delay? How it affects the combustion process in SI engine. So, in abnormal combustion called detonation, the end charge auto-ignite before the flame front reaches to it. To auto-ignite, the last unburned charge must reach above critical temperature and remain at this temperature for certain length of time. This time required in the chemical preparation is called ignition delay. The ignition delay period is longer than the time required for the flame front to burn to the unburned charges. There will be no detonation in SI engine. Only when the critical temperature is reached and maintained and the ignition delay is shorter, the time it takes for the flame front to burn throughout the unburned charge, there will be detonation. The higher compression ratio that can be used in an SI engine is limited by the detonation characteristics of the available fuel. Justify the statement. This is also a question, an assignment for all of you. So, we cannot increase the compression ratio beyond certain limit in SI engine. So, what is the reason? So, answer is in normal combustion, the flame started by spark travels across the combustion chamber. As the flame front advances, it compresses the unburned charge in the last portion of combustion chamber. If this unburned charge does not reach its critical temperature for auto-ignition, it will not auto-ignite the flame front. Will move across these unburned charges in normal manner. In abnormal combustions called detonation, the end charge auto-ignites before the flame front reaches it. In order to auto-ignite, the last unburned portion of charge must reach above the certain critical temperature and remain at this temperature for certain length of time. During this period, certain chemical reaction takes place which prepare the charge for auto-ignition. The time required in this phenomenon is called ignition delay. In order to limit detonation, we should now allow the unburned charge to reach its critical temperature. Increase in temperature of mixture reduces delay period and end charge. Hence, tendency of detonation increases. Increase in temperature is obtained by avoiding detonation. We should limit the compression ratio, hence there is a critical compression ratio for a fuel for a given engine setting above which now occur. This compression ratio is called highest useful compression ratio. Thank you.